I've been writing and planning this film for approximately a year. I wasn't sure how soon I'd be able to make this while constantly having to find work to pay my rent. But now I'm under the COVID lockdown. What work I did have is cancelled, and I have nothing but time to fill. So, this is clearly the time. I actually had much more ambitious plans for how I was going to film and present this, but I started the first day of filming downstairs a few days ago, outside my front door, with my stepdaughter Freya filming me. And after only a few minutes, a neighbour came out and shut us down, because me and Freya don't actually live together. She told us to go home and wash our hands. So I have to make this film on my own, and I have to do it without going out and about in the world as I was intending. I will make this film entirely on my own and entirely inside this flat, or just outside the front door. I have 10 years worth of video work and music making on my hard drives, so that will be my main reservoir of cutaway footage and soundtrack, though maybe I'll resort to stock video footage occasionally. My name is Ian Moore. Most people who know me call me Yanto, because I lived in Wales for quite a few years. So Ian Moore and Yanto, we are a storyteller, essentially. That's what we like to do. And the story we're going to tell is a true story. We know it's a true story because it happened to us. And if it doesn't change your life, if it doesn't change the course of history for this planet, it's only partly our fault. The other part is yours. Because even if I tell this story badly, it's so simple, you won't really have any excuses. What happened is I watched a video on YouTube. It's really a very innocent and innocuous video about the history of our search for the definition of the word number. And as innocent and innocuous a video as it was, I noticed something in it that caused me to say, "Oh, that's interesting." And I had to think about it a little bit. And then I had to think about it a little bit more. And then a little more. And then one thing led to another, and then I had to make this film because, well, I just had to then. This video is a 9-part lecture on the nature of existence. The reason it changes everything is because this is the moment where we finally get the big existential answers, the ones that we have been looking for so long and become so used to not having them that we've become resigned to not having them. And it all turns out to be so simple and breathtakingly self-evident, it almost hurts. Maybe it does hurt. And if that idea makes you nervous, then you should probably stop watching now, because once you know it, you won't be able to unknow it, because it really is that simple. So that's what's happening here. Shall we dive in? Do you want to go to the toilet first? Okay, so here we go. Are you ready? So did you know that our fields of maths, science and philosophy do not know what a number is? It's the darndest thing. I didn't know. I didn't know myself until I watched a video last year on YouTube about the history of our search to define what a number is. I'm going to give you a potted history of the whole story, but I strongly encourage you to check out the video itself for the full detail. Link in the description below. Up an Atom is a fun channel for maths and physics nerds. Watching this video actually only caused a tremor in me at first, but I did feel compelled to keep thinking about it, and it wasn't that long before I came to the point where I couldn't ignore how catastrophic the thinking is that runs through almost all of it. As I tell the story, I encourage you to be on the lookout for any parts of it that do make some sense to you. We start with Plato, the famous Greek philosopher. Plato believed that numbers, geometric shapes, and the relationships between them are objective truths. He described numbers as objects that exist in their own specific realm of existence, which he called the world of forms. Next came Aristotle. Aristotle was a student of Plato's. He didn't like all of this numbers are objects business. As far as Aristotle was concerned, it didn't make any sense to say that if you have 4 cows in a field, then the cows are objects and the number 4 is also an object. So Aristotle defined numbers as properties of objects. Time passes, and then along comes Gottlob Frege. Up-and-Atom describes him as a god amongst us, the hero of the story, and he was pretty on the ball. He wanted to define the foundation of mathematics as logicism. In other words, he believed that mathematical truths are what they are because they simply, logically, cannot be otherwise. He also recognized the difficulties that can arise from use of language. He began to develop something in maths that would become known as set theory, to solve the issue of what numbers can be said to be the property of collections of objects of similar types. For example, is a deck of cards one deck or 52 cards? Which number applies? This may seem a fairly inconsequential question, but to be precise about this kind of thing is to watch for cracks in the foundation of your theoretical system. And Frege was specifically trying to identify the foundation of maths, so precision of language was vital. Frege described numbers as extensions of concepts. He worked very hard on this and was underappreciated in his time, but he made a fan of Bertrand Russell, who really liked his rigorously logical thinking. Russell, unfortunately and ironically, liked Frege's work so much that he looked at it hard enough to spot an error. As a result of this, Frege had a breakdown because years and years of his work had gone down the drain. Russell tried to fix Frege's work because he really didn't want it to be broken, but he wasn't especially successful. Up-and-Atom ends her video with these words. Anyway, after a series of fortunate events, the foundations of mathematics is now known to be a system called Zermelo-Fraenkel set theory, which has a lot of Frege's original ideas incorporated into it. Ah, a happy ending. Only she had one more thing to say. But, although this is the most widely accepted theory, the search still isn't over, with candidates like category theory and homeotopic type theory becoming serious contenders for that much desired position at the bottom of the math tree. So, we still don't know what a number is. What a stern gathering of hard-thinking fellows. But we can't fault them for trying. And we still don't know what a number is. And we still don't know what a number is. But that's not going to be all that important, is it really? Well, it turns out to have staggering consequences. Let's work our way backwards, from the happy ending to the beginning of the story, And let's be on the lookout for any parts of the story that do make some kind of sense to us. So the happy ending. We still don't know what a number is. That's not so easy to be happy about. Zermelo-Fraenkel's set theory is intended to give us the foundations for mathematics, but it doesn't succeed. There are enough intricacies in it for it still to be in doubt. A foundation, a true foundation, does not actually have intricacies. When we look to identify our foundation, we look to identify the absolutely simplest rock-bottom truths, which are self-evident in and of themselves, and from which intricacies can emerge. Zermelo and Fraenkel do not provide this. So this brings us to the foundations of Zermelo-Fraenkel set theory, Frege. Frege sought to establish logicism as the foundation of mathematics. Here is something in our story that is, to me at least, a reasonable proposition. Frege sees the necessity of a solid foundation, and he works through long and hard years of obscurity to identify what it must be. The dynamic between Frege and Russell is telling. When Russell finds a paradox in Frege's work, it's not because he is trying to break Frege's work. On the contrary, he points it out to Frege because he wants it to be fixed, because he also sees the need for a strong and rational foundation for mathematics. But something interesting happens here. Frege has his breakdown because his life's work has gone down the drain. Russell feels bad and tries to fix it. Take a moment to think about the behaviour of these two men that are both so devoted to logic, to reason. Frege, who has been working for years and years on this, recognises his theory is broken. He doesn't have a breakdown on a whim. He knows his own theoretical system well enough to see that it really is broken. Russell, on the other hand, has not been familiar with Frege's theory for all that long, and he feels bad on two accounts. One, he wanted Frege's work to be correct, because above all he respected logicism. Two, this man that he admires has now had a breakdown as a direct result of him correctly identifying that Frege's work is broken. So Russell does what an apprentice of pure logicism should never do. He tries to fix what can only logically be broken. He tries to make correct what is incorrect, not for reason, which is so important to him, but for emotion. Russell doesn't succeed in his attempts to find a fix for the simple reason that there isn't one. What is broken, but his heartfelt efforts, along with his status as a thinker, encourage others to pick up the challenge. Hence, Zermelo and Fraenkel and our happy ending. Frege didn't have a breakdown because he suspected he had spent years of time and energy on a mistake. He had a breakdown because he knew he had spent years of his life on a mistake. He knew his work better than anybody, and he saw the situation more clearly than Russell, Zermelo, or Fraenkel. A pure logistician accepts the truth when it is seen clearly enough. Frege saw the truth of the matter. Numbers are not extensions of concepts. In the end, Frege knew it. What then of Aristotle and his numbers are properties of objects? Here is where we come to the heart of our story. In order to tackle this, I'm going to bring in another renowned thinker to help me. He has been described as the greatest philosopher of the 20th century, and inevitably he has some connections to our soap opera. His name is Ludwig Wittgenstein, and in his early years he was a student of none other than Bertrand Russell. Wittgenstein and Russell had an intense relationship which soured later on. Russell lost patience with his former student. But in the same way that Frege was the hero of Up and Atom's story, Wittgenstein is the hero of mine, and he'll be cropping up throughout this lecture. Wittgenstein proposed that most problems in philosophy can be attributed to language use. Now, at first glance, that statement doesn't seem all that clever of a thing to be famous for, does it? Well, we'll see how that plays out as all of this unfolds. But for now, what are the problems of language use that come into play when we look at Aristotle's numbers are properties of objects? Aristotle rejected his own mentor's proposal that numbers are objective truths. For him, it didn't make any sense to say that if we have 4 cows in our field, that the cows are objects and the number 4 is also an object. Now this sounds eminently reasonable, but what is happening with language use here? Essentially, what Aristotle is saying here is that it is objectively true that a cow is a cow, and the number of cows we have emerges as a property of the presence of the objective truths which are the cows. It must do, because a number is clearly and self-evidently not an object, like a cow is an object. That Aristotle should view the cows as objectively true is not surprising in the least. It also just happens to be the greatest error in all maths, physics, and philosophy. Why? Why is this an error? Well, Aristotle sees objects as being objectively true, and the language use supports him. Our cows are objects, therefore they must be objectively true. From a language point of view, that seems perfectly self-evident. Let's take a look at our cows. Our image here seems straightforward enough. We could perhaps say it's a little overly simplified. What happens if we introduce a little variance? Not all cows are the same after all. Here we have a bull. Does a bull qualify as a cow? Is a cow a female bull? Is a bull a male cow? They both belong to the same animal species, but what is that species called? Cattle? Here we have a calf. Is a calf a cow? Here we have a bison. Shall we count it or shall we not? It was exactly these kinds of queries that Frege had sought to resolve, and it took a long time and a Bertrand Russell for him to understand that they couldn't be resolved, not in the way he wanted them to be. The truth, it turns out, is that when we have 4 objects, 4 cows in our field, it is objectively true, regardless of anybody's opinion, that there are 4 of them. Whether they are cows or not is a matter of opinion. But we have avoided this precision of language despite its straightforward self-evidence, and Wittgenstein watches on and nods knowingly at the confusion. Plato identified numbers, geometric shapes, and the relationships between them as objective truths. This is simple and self-evident enough. An objective truth is something that can be said to be true regardless of anybody's subjective opinion about it. 1 + 1 always equals 2, regardless of whether you or I agree that it does. And that is really not a difficult thing to understand at all. Here's something interesting I observe about the shifting place of objectivity in our theoretical system of maths. Plato introduced objectivity and gave it to maths. Aristotle immediately took objectivity from maths and gave it to physical phenomena. Frege conceded that objectivity and physical phenomena do not go together. He can see that maths applies to more than just the physical. 1 + 1 can be applied to thoughts, emotions, concepts, just as easily as to cows in a field. As he's working on a foundation for mathematics, he removes the issue of physical objects from the problem. As he can't see where objectivity goes, he removes that from the problem. And that's where the baby gets thrown out with the bathwater. So why? Why don't our great thinkers want number and maths to be objective? Why are they so set on fixing the unfixable contention that numbers are subjective when they simply and self-evidently are not. That's the question I was asking myself when I watched the video, when I said to myself, oh, that's interesting. It's not the kind of question that immediately blows one's mind. It feels more of a minor curiosity. But because I found it mildly curious, I thought about it a little more. And this led me to having a thought I had never had before. A thought I had never heard from anybody else my whole life long. And this changed everything for me. The thought is this: not only do numbers and mathematics qualify as objective truth, but they are literally the one and only objective truth in all of existence. What's this, I say? Well, you can check it for yourself, very simply. Take a pen and paper, sit down, and make a list of all of the objective truths, all of the objective phenomena in all of existence. That might sound like a big task, but it isn't, because there is only one item that can possibly go on that list. Correct mathematics are the only example anywhere of something that is objectively true, perfectly immune to individual opinion. Now, it might seem to some of you that I'm being unhelpfully pedantic about the definition of objective here. But the thing is, the use of the word objective is far too pivotal in philosophy for us to be unclear about it. If the word is not allowed an absolute meaning, then the very foundation of our understanding is in doubt from the start. If the word really has become that unclear, we could just invent a new word that does mean what objective is supposed to mean and use that instead. If we're talking foundationally, we're talking fundamentally and absolutely. There's no room at the foundational level for complex and debatable vagaries. The foundation is inherently composed of the simplest and most absolute of truths, or it is not a foundation. And how on earth can we be confident in objectively defining our foundation if we can't tell what qualifies as objective in the first place? So, again, why? Why do our great thinkers seek to duck the objectivity of mathematics, seemingly at all costs? One might expect a mathematician to be pleased about it. The answer is perfectly simple, natural, and easy for us to appreciate. As humans, we share a cognitive bias that goes something like this. That which is physical is real. That which is not physical can only be subjectively experienced, which makes it therefore less than real. And this is an extraordinarily natural cognitive bias for animals like us to have. What is imperative for an evolving animal species, first and foremost, in its earlier stages of development, is for it to relate to the physical world in an effective way so that it may survive and propagate. But when it comes to the animal developing an understanding of the deep truths about the nature of existence, that cognitive bias is no longer so useful. It leads us to conclude that all that is not physical can only be abstract. Mathematics are not physical, therefore they cannot be objective. And so, we get the cyclical pattern in our story. It is one continuous story of the attempt to fix broken fixes, because the actual truth, we just cannot see it to be true, even when we try hard. When we try to think of mathematics as being objective truth and cows as being subjective, it just hurts our heads and we have to stop, because To have maths come before matter means something weird that we can't quite get our minds around. Plato must have been quite an odd fellow in his time. Aristotle's error can't be fixed, because when we make all objectivity in existence subject to the subjective, properties of objects, extensions of concepts, we are removing the actual possibility of objectivity from our system of thought. That's the nub of it right there. That's just how it is for us right now. We came up with the word objective, we use it on a daily basis, and yet nobody has noticed that ever since Plato, we have never once identified an actual candidate for the word to apply to. This is an entirely controversial statement. It's also very easily made because it's so patently true. Here we arrive at the key question that part 1 has been heading towards. What does it mean that the one single objective phenomenon in all existence is non-physical? This lecture will be covering a lot of ground in terms of understanding how existence works. But the most challenging concept for almost any human to entertain is the idea that physical phenomena could possibly have a non-physical cause. That seems a logical impossibility to us. It seems utterly implausible and irrational. Our cognitive bias can't cope with it. But there is a logic question that serves to counter that reaction. How can physicality be cited as the underlying cause of physicality? How can physicality be cited as the cause of physicality? Why, that would be a paradox, would it not? To say that the underlying reason for the existence of physical phenomena is itself a physical phenomena doesn't actually make any sense at all. And if you find a paradox in your theoretical system, that's an indicator that your theoretical system is broken, isn't it? Ask Frege. He knows all about that. So the very cognitive bias that we base our understanding of maths and science on, that physical means real and non-physical means not real, turns out to be an actual system-breaking paradox. Nikola Tesla said, "The day science begins to study non-physical phenomena, it will make more progress in 1 decade than in all the previous centuries of its existence." If Tesla said that, but didn't actually go ahead and accomplish it himself, I can only guess that he didn't know where or how to start. None of us have known how to go about studying non-physical phenomena, not objectively. How would we even begin? But when we understand that there is only one objective phenomena in all existence, and that phenomena also happens to be non-physical, there is suddenly only one place we can start. In this video, I will be showing how objective truths, such as 1 + 1 = 2, that have no inherent physicality of their own, do indeed determine both the presence and behavior of actual physical phenomena. In part 2, I will show how fixing Aristotle's error tells us at long last why existence bothers to exist at all. And I'll also tell you what the true definition of number is. So last time, we looked at the search for the definition of number and examined why it has proven so difficult for all of us, even mainstream mathematicians who are passionate about mathematics and very much aware of their power, to think of mathematical truths as objective facts. What might help with that? Our cognitive bias tells us that only physical things can be considered to be real, but logic tells us that citing physical phenomena as the underlying cause of physical phenomena doesn't make any sense. Logic trumps simple old bias, no matter how attached we are to the bias in question. But how can something non-physical, something that has no inherent mass or energy of its own, be the cause of physical effects that are entirely equated to mass and energy? When asked this question cold, the human mind goes kind of blank. It has no frame of reference to even give it a starting point, a place to begin looking for clues. It's not until somebody comes along and points out that there is actually only one objective phenomenon in all of existence, and that objective phenomenon also happens to be non-physical, that we get a potential lead, a place to start. So let's see if we can make some sense of this. We have a lead at last. Let's go investigate. Let's look at the difference between two ideas. Ideas are non-physical, but some ideas are objectively true, while others are only subjectively true, if that. So for example, we can take the idea that I think I'll have soup for lunch today as a subjectively true idea, and the idea that 1 + 1 = 2 as an objective idea. The key difference between these two ideas is that one of them holds true at all times, regardless of whether it is being thought about or not, regardless of whether it is agreed with or not, while I think I'll have soup for lunch today only holds true while it is being thought. While I am thinking, I think I'll have soup for lunch today, it is true that I am thinking that. But as soon as I start thinking about something else, it is no longer true that I am thinking, I think I'll have soup for lunch today. The soup for lunch idea is incredibly fleeting. It's ephemeral. It emerges from the mind, and then, sooner rather than later, it dissolves into a memory that is likely to be forgotten sometime soon. Perhaps the idea will lead to me actually having soup for lunch, and perhaps it won't. 1 + 1 = 2, on the other hand, is true at all times, regardless of whether it is even being thought or not. That is not some small and insignificant difference. It is a profound difference, more profound than we have appreciated. The real difference between these two ideas is that one of them is an idea and one of them actually is not. 1 + 1 = 2 can feel like an idea when we think it, because when we think it, it actually is an idea that we are having. But 1 + 1 = 2 is an objective truth that is always in effect, always holds true, always has and always will. We can think it as an idea, but it really is objectively true, even when we are not thinking it. The reason that non-physical but objective truths are absolutely more powerful than any other thing in existence, despite them having no inherent mass or energy of their own, is that they hold true at all times, always and forever. If an objective truth did have a physicality of its own, then it would, by definition, be subject to change over time, just like all of the rest of the physicality in the universe. Objective truths are the one unchanging phenomenon in all existence, while the rest of existence can only change over time in accordance with the objective truths. Here is where you can get the difference and the significance. Existence can only ever do what objective truth determines. There can be no example in all of existence, all of history, the current moment and the future, of even the tiniest speck of existence doing anything other than what objective mathematical truth tells it must do. Are you beginning to see? There is literally nothing here to argue with. Objective mathematical truth applies to absolutely everything, to the physical, to the non-physical, and even to itself. Physical, 1 cow plus 1 cow is 2 cows, so long as we agree on what constitutes a cow. Non-physical, 1 thought plus 1 thought is 2 thoughts. Mathematical, 1 equation plus 1 equation is 2 equations. Nothing, absolutely nothing, is exempt. You could have all of the power, mass, and energy in the universe, and you would still be able to do nothing, not a single thing, that mathematical truth didn't tell you you absolutely must do. Do you get it? You may feel a strong desire to resist this cognitive shift. If you do, then you probably will. It makes not one jot of difference. So, this is all a bit weird, isn't it? The idea of being absolutely governed by maths, down to your most intimate personal thoughts and emotions. It doesn't ring true, does it? It doesn't feel that way, does it? So far, Yanto's making a pretty compelling argument, but still, I don't feel like I'm being absolutely determined by maths. And that's a relief, actually, because the very idea of it is utterly terrifying. I don't want to be a computer program. It's all right. It's going to be all right. Through the course of this lecture, I'm going to be dropping a number of philosophical bombshells. And each time I do so, you're very likely to immediately skip ahead in your mind to what you feel are the unavoidable conclusions of that bombshell. If I say every minute aspect of you is absolutely determined by maths, you may immediately think, well, if that's true, that means I can't have any free will. That thought may seem inescapable. Be assured, be reassured. In the same way that I will make it clear how physical stuff can be caused by non-physical stuff, I will also be making it clear how you can be entirely determined by maths, yet still have free will. Try not to jump to conclusions. Put your assumptions on hold. Existence is quite a lot to unpack. I can only do it a bit at a time. If the intention of this lecture is successful, your cognitive bias is going to shift. And for many people, that may be a frightening prospect. But after your cognitive bias has shifted, you will still be you. And your world will still be your world. You'll just understand both you and your world better. That's all. And that understanding will be of more help to you than you can imagine right now. So what next? Well, one of the biggest themes of episode 1 was this concept of identifying the foundation of maths, science and philosophy. You see that tall imaginary building over there? That skyscraper is what we are building with our current understandings of maths, physics and philosophy. And it is undeniably impressive. And I mean that sincerely. You see how high it is? Pretty much all of the thinkers are up there on the top floors. The top floors are the frontier of human knowledge and understanding, where the thinkers go to investigate all of the higher truths. Whether they are mathematicians or scientists or philosophers, it's those higher floors they are attracted to, like moths to the flame. We want the higher truths, the higher maths, the higher mysteries, and we're so close. So close. Just look how close we are. We don't know what a number is still, and we're a bit confused about objectivity and subjectivity, but look, that hasn't stopped us from building this miracle of engineering. Now, it may sound like I'm slyly criticising, but I'm really not. We've already seen that all sorts of people have tried to establish a foundation. It's not that they don't see the value in it. They've tried really hard, and they have come up with the best working solution that they could, given the ingredients they had at hand. And look, it is keeping the building up. This foundation has a few cracks, admittedly, but it's doing the job, and that is something to be thankful for. The thing is, a building of that scale, if it is to keep growing taller, keep taking us higher, it needs a foundation that is situated on pure bedrock. Mathematical bedrock, scientific bedrock, philosophical bedrock. I'm talking about the simplest, purest, most primary truth there is. The answer that does not beget yet another question. We can ask how the universe is here, and we can be told the Big Bang. And inevitably we ask, so what caused that? We can tell a child that God created the universe, and we know that child is then going to ask, but where did God come from? Bedrock is the place where those lines of questioning arrive at the final stop. Bedrock is that answer which, when we hear it, we simply don't have a follow-up question, because our question has actually been definitively answered. Bedrock tells us why existence bothers to exist. The thinkers up there on the top floors are not idiots. If they could have built that structure on bedrock, they would have gladly. It's just that none of them have known where to look for it. So they've made the most of what they have found, and the results truly are breathtaking. Please don't think for a moment that I'm wanting to undermine their achievements. Quite the opposite. My admiration is genuine, it really is. I wasn't expecting to find bedrock. I wasn't even looking for it. It just sort of happened, because of that bloody video I watched. So look, here's how it is, objectively, whether you agree or disagree, whether you like it or not. The foundation of maths, physics, philosophy, the foundation of existence itself, is logicism. I know it's not a very nice word, but it's just a word. We can call it objective truth, if you prefer. I'm not a religious person myself, but I don't have a problem with you calling it divine truth, if you like. All it really means is the truths that are true simply because they just can't not be. That's it. That's all logicism is. That which simply cannot not be true must therefore be true. There's nothing there to argue with. Logical truths can be simple, foundational, and if you gather a bunch of them together, they can become infinitely complex. And the only language that is fit to tell all of the objective truths with exact precision is maths. Bedrock is the simplest, most fundamental, logical, objective truth that tells us why existence bothers to exist. And once we reach bedrock, we can begin to build a new building on a foundation that isn't weakened by cracks. Mathematical truths are not abstract concepts. It's true that they have no mass or energy of their own. They have no substantive reality of their own. That is true. And yet, they determine the continued presence and activity of all existence. How did they do this? How did they cause the universe that we know and love? There is one simple mathematical truth that answers the question, why does existence bother to exist? And this is bedrock. Just as 1 + 1 = 2 is eternally true, simply because it just cannot not be true. Absolute nothing is an absolute impossibility. You can have 0. You can have 0 bricks, or 0 cows, or 0 apples. But you can't ever have 0 everything. Absolute nothing equals 0 everything. And 0 everything is a literal impossibility. And that is an objective mathematical truth. In other words, it is a thing that cannot ever not be true. And all of the power, mass, and energy in the entire universe can't do so much as scratch that. This is what science's law of conservation of energy expresses. Energy cannot be destroyed or created. It can only change form. Existence has never not existed, and it never will not exist. Existence did not come into being, but rather, existence has never been allowed to not exist. Never, ever. We've literally never had our bedrock before this moment. That's not to say that I think I'm the first person to have this particular idea. I don't think that for a second. But now that we feel brave enough to bring ourselves to recognize that mathematical truths are objective, that they literally can never be broken, we effectively have both the reason and the mechanism for existence. But what do we do with that now we've got it? How does it help us to build the model of existence that is actually correct? The thing with the foundational truth is that it is inherently extremely simple. And once you know it, you know that it applies at all times, in all locations, in all contexts. So as we are progressing through this lecture, we are building our new structure, our model of existence. And as it gets higher and higher, we know that the bedrock principle won't only be located down in the foundation. It will be fully present and correct on the higher floors as well. Remember that, because as we move up, there will be times when the bedrock principle helps us out. For now, just understand this. Whether this universe came from a Big Bang or not, existence itself never came into being. Existence has always existed, and it always will. It gets no choice in the matter. And this isn't because objective truth is a tyrant. Objective truth has no agenda of its own. It was not elected to be true. It was not designed to be true. It is not a creation. It was not written in advance. It is just what cannot be untrue under any circumstances. It's not trying to ruin our day. I'm not trying to ruin your day. It has no body and it has no mind. It has no mass. It has no energy of its own. But it's got us all the same. Absolute nothing is impossible for the simple reason that it happens to be objectively, absolutely, unbreakably true. Therefore, you exist. I am that I am. Welcome to Bedrock. Now that we are on board with Plato and that numbers are objective truths, our definition of number becomes the objective element in any value we identify. My definition for number is: a number is the objective quantifier that states the distance of a value from zero. In order for this definition to work, we also have to be precise about what the word value means. A value is the combination of a number, objective quantity, with a quality. And now we need to be precise about our definition of the word quality. A quality is that which is sensed, measured, observed, experienced, as defined by the observer. And so, when we plot on a graph a value such as 4 cows, the number 4 is telling us that we are 4 cows away from 0 cows. This is the objective quantity of our value, its distance from 0. The word cows is whatever we say it is. This is our subjective quality. This may sound horribly unscientific, but it has always been the case. This definition is the simple truth of how measurements are made, and it's paradox-free. If your mathematical system doesn't recognize this, your mathematical system is incorrect. In part 3, as a direct result of clearing up the definition of number, I will present my solution to a maths problem that has gone unsolved for hundreds of years, and this solution will unlock some profound implications. I'm kind of excited about it. So how do you find the square roots of a negative number? And why should you be interested in the slightest? The square roots of any given number, let's call the given number x, are those numbers that, when multiplied by themselves, give you x. +1 times +1 gives you +1. And -1 times -1 also gives you +1. Multiplying a positive number by a positive number always gives you a positive result, and multiplying a negative number by a negative number also always gives you a positive result. What then can be the square root of -1? What then can be the square root of any negative number? That question is a real brain twizzler. When I try to imagine what that number must look like, I can only assume it's some strange and exotic thing. But how could it be? Numbers are so simple. One number is either greater, smaller, or the same size as another. There's not really that much more to say about them. Identifying the square roots of negative numbers is one of the unsolved problems of maths. And because it has proven to be so difficult to solve, a hack was invented to get around the problem. This hack came to be known as imaginary numbers, and it proved to be very successful. It's such a successful solution that we've been using it for hundreds of years now. And the general feeling I get is that imaginary numbers are so well established now that many people don't even know they are a hack and mistakenly take imaginary numbers to be the true answer to the problem. Does anybody even think to try to work out the actual solution anymore? There simply doesn't seem to be much necessity to do so. Well, I did work it out. And I did so by accident when I was thinking about something else, as usual. And of course, it's necessary. It's basic maths, which makes it foundational maths, which makes it massively necessary with real-life consequences. So in the last 2 parts, I've been making a whole lot of fuss about how fixing Aristotle's error changes everything for us. Our prior inability to see that non-physical truths actually tell physical matter how to behave acted like a brick wall for us. All we've been able to do is come up with more and more inventive hacks for getting around that wall. And if, hypothetically, somebody were to come along and take that wall down, one would reasonably expect all sorts of previously unanswered questions to suddenly become clear. Now, there's something I haven't told you about myself, and it's important that I tell you now. I'm not very good at maths. I'm really not very good at maths. The highest maths qualification I have is the B I got in high school. With my current knowledge and ability, I would never take it upon myself to set out on some mission to solve mathematical problems that have flummoxed real mathematicians for hundreds of years. But solving it just happened spontaneously while I was thinking about the implications of fixing Aristotle's error. And I feel ever so encouraged, because if, as a result of that, I can suddenly start solving problems that specialist mathematicians haven't been able to, that suggests to me that I'm on the right track, that my Aristotle fix is real and true. So it's not a question of me being good at maths. I'm really not. I just stumbled on a thought that turned out to be helpful. Sometimes, when a room full of people are fumbling around in the dark, one of them finds a light switch. And it doesn't have to be an electrician to do it. That's a pretty good analogy. So let me walk you through what happened. I identified Aristotle's error, and I went ahead and redefined a number as being objective. And then I started to ask myself what all of this so far could tell me about how reality truly works. As far as I'm concerned, objective truths are writing existence, non-stop, full stop. So what does that look like? The key decision I made fairly early on was that I wanted to look at this new definition of numbers in 3 dimensions because of the following line of reasoning. 1. I know that as a human being, I have a natural cognitive bias towards understanding things in 3-dimensional terms. Basically, I just wanted to make it easier for myself to picture this stuff in my mind. 2. The information difference between 1 and 2 dimensions, or 2 and 3 dimensions, the difference in how much stuff is happening, is utterly vast. Too vast to fully appreciate, I'd say, because it's infinite. 3. I wanted to explore how numbers could effectively cause and determine existence, and I didn't see a way to even think of existence in only 1 or 2 dimensions, because nothing can exist in only 1 or 2 dimensions. For example, if we look at numbers in 1 dimension, we get a number line, centered on 0 and reaching to infinity in both the positive and negative directions. But despite it reaching towards 2 different infinities, a 1-dimensional world cannot exist because it has no thickness to it, no body, so to speak. There can literally be nothing there. 1-dimensional existence is a truly abstract proposition. You might think that things would improve when we add a 2nd dimension. Now we have height as well as breadth, creating an infinite 2-dimensional plane. But this infinite plane still suffers from the problem of having 0 thickness. A membrane with 0 thickness is a membrane that literally isn't there. We can use this plane to study the relationships of numbers in the abstract, but when it comes to studying how numbers relate to reality, It can't make complete sense because it can't contain enough information. If reality itself requires a minimum of 3 dimensions for it to exist in any real sense at all, and reality is entirely determined by mathematical objective truths, then we are required to observe numbers as 3-dimensional objects. To restrict ourselves to looking at numbers in only 1 or 2 dimensions is to restrict ourselves to only looking at wafer-thin slices of reality that could never even function as a reality on their own. Did you follow that? It's such a simple way to see it. But we do not think this way. Why should we make life any harder and weirder than it already is? So, maths, which is objective truth, writes existence. And existence requires a minimum of 3 spatial dimensions to be there at all. Therefore, when looking at how maths affects reality, it is necessary to do so in at least 3 dimensions. That's simple thinking. That's logicism, by my definition at least. So I started to think of numbers 3-dimensionally. When we plot 1 on a 1-dimensional number line, we make a small mark of some kind to indicate the distance of 1 from 0. In 1 dimension, the distance from 0 is a straight line. In 2 dimensions, the distance of 1 from 0, our new definition of number, remember, would naturally be indicated by a circle. In 3 dimensions, the distance of 1 from 0 produces a sphere. It's only now, at 3 dimensions, that we encounter numbers as things we would recognize as objects, as Plato said they are. But looking at numbers this way presents us with a curious new problem. Yes, we can plot 1 as a sphere, just like this. But assuming we have just plotted positive 1, where would we plot negative 1? Well, negative 1 would be plotted in the exact same location. This is when my light bulb goes on. When we look at positive 1 and negative 1 on a single number line, we can see clearly and definitively that they are 2 very different numbers, occupying 2 very different locations in relation to 0. But when we plot them in 3 dimensions, we see clearly that they are in fact the same number, and it is only the polar quality that differs between them. +1 and -1 have the same number. Today's mathematicians see this as a number. It is not. This is a number. This is a polar quality. They are 2 distinctly different things. The number represents the objective quantity, the distance from 0, and the plus and minus signs relate to the subjective quality, as defined by the observer. They are different things, and that is why we use different symbols to represent them. Wittgenstein said that most of the problems in philosophy can be attributed to language use. Here is a super fine example. The definition of square root refers to a number being multiplied by itself. There's a double language use problem here. The first is simply that the word number has not been correctly defined. The second language use problem is the insistence that a number even can be multiplied by itself in the first place. It can't. When you multiply 5 meters by 5 meters to get a square of carpet that's 25 square meters, you're not multiplying 5 by itself, you are multiplying 5 by a second instance of 5. These two 5s are not the same quantities. They are two distinct quantities. This one is width, the other is height, that happen to be of an equal distance from 0. That is why there are two instances of 5 in the equation. Multiplying one quantity by a second quantity of the same size is possible and makes sense. Multiplying one quantity by itself is nonsensical, impossible, and has no place in any working theory of maths. Here is how I would note it. The square roots of +1 are ++1 and -1. The square roots for -1 are +-1 and -+1. So the square roots of +1 are +1 times +1 and -1 times -1. Here we have two cases of one number being multiplied by a second instance of that number to arrive at +1. The square roots for -1 are +1 times -1 and -1 times +1. And this is two cases of one number being multiplied by a second instance of that number to arrive at -1. Just take a look at that. That is math with clean lines. You can see the self-evidence just beaming from it. But that hasn't been allowed, and the main reason for that is that mathematicians are great with numbers, but comprehensively questionable when it comes to using language. Yes, I only got a B in maths when I was at school, but I did get an A in English language. Just saying. So, please pause a moment so we can think about what just happened there. That was easy, wasn't it? That mathematical problem has gone unsolved for hundreds of years, but the answer turned out to be so simple. We thought the square of a negative number must be some strange and exotic kind of number, and so we got on board with imaginary numbers. They felt just about strange and exotic enough. We need to learn how to think more simply. There was once a mathematician called William of Ockham. He was a friar. He kept telling everybody to keep it simple. He said it over and over. Have the minimum possible number of moving parts in your system. He was quite passionate about it. So we learn that the principle of keeping it simple is known in mathematics as Occam's razor. And then, once we've learned that, we tick it off the list of things to learn and we get on with doing whatever we were going to do in the first place. So, imaginary numbers, complex numbers, let's keep them simple. When I watch videos about maths and physics as a layman, I'm really just following the stories of maths and physics. Naturally, I'm a storyteller. When I hear that the invention of imaginary numbers led to the discovery of complex numbers that have proven to be fundamentally useful, the story I hear is that basically, when you take the x-axis number line, make a copy of it, and then rotate it to form the y-axis, the imaginary number axis, what you are saying is that you have a normal xy axis here, but both axes are two dimensions of one quality, because the y-axis is a copy of the x-axis. So complex numbers are basically what you get when you are measuring two dimensions of one quality. Both dimensions, or sub-qualities, belong to the one quality. And yes, that is a fundamentally useful thing to be able to do. If we carry that reasoning forward to the next obvious step, given my feelings about looking at numbers in 3 dimensions, I suggest that the bare minimum of numbers we should be working with when wishing to understand the behaviour of reality is those numbers that can be found in the infinite complex plane of a three-dimensional space. If you think about it, why on earth would we choose to restrict ourselves to two-dimensional thinking so much of the time when reality can't even function in only 2 dimensions? Well, it does sound like an awful lot of numbers to crunch, but we have computers now, so maybe it's not too bad. The reason this idea excites me is because currently we have this general and muddy kind of view of polarities, which I'm calling polar qualities. We seem to think, as far as I can tell, that there are only 3 polar states: positive, negative, and neutral. But this is only true when we plot a quality on one number line on one axis. As soon as we give the same quality 2 axes, the complex plane opens out, and suddenly we have infinite complex polar qualities. And as soon as we give that same quality a 3rd polar axis, a 3rd dimension, we begin to simulate the 3-dimensional existence that makes most sense to us and actually does have a chance of functioning. The easiest way I can think of to illustrate what I mean is to choose the most visual quality I can think of, which is colour. There are infinite qualities in existence, and colour is just one of them. But colour itself has an infinity of qualities, or in other words, there is an infinity of potential colours. Once a living organism has developed the ability to perceive the quality of flavour, it can then discover there exists an infinity of potential flavours. Once a living organism has developed the ability to perceive the quality of colour, it can then discover there exists an infinity of potential colours. I'm going to introduce you now to the visual image that has supplanted the yin-yang, in my view, as the most spiritually satisfying image I've ever seen. I found this image on the website of a company that makes colour printers. This is a colour sphere. For me, this is the perfect object to demonstrate the relationships of the 3-dimensional polarities of any given quality. So as I said earlier, for a thing to exist, it requires a minimum of 3 dimensions, 3 distinct axes that define what that quality can be. In the case of colour, these 3 axes can be identified as the luma axis, the saturation axis, and the hue axis. The luma axis in this image runs from top to bottom and indicates the amount of light that must be present for a colour to be discernible as a colour. Once you reach absolute white at the top or absolute black at the bottom, you have reached the limits of a quality that can be considered a colour. The saturation axis runs from the centre of the sphere to the outer edge and indicates how saturated or intense a colour is. Once you reach the absolute centre of the sphere, you have reached the limit of 0 colour saturation. Perfect white at the top of the sphere is no longer a colour, perfect black at the bottom of the sphere is no longer a colour, and perfect grey at the centre of the sphere is no longer a colour. The 3rd axis is hue, and this axis doesn't run from one side of the sphere to the other, as the luma axis does, and it doesn't run from the centre to the outer edge, as the saturation axis does. The hue axis rotates around the luma axis. In this way, the colour sphere naturally provides a mathematical location for every possible colour to exist. It seems utterly self-evident to me that any quality that can be conceived of must have 3 defining dimensions, 3 sub-qualities, as our colour sphere does. One polar quality will run from top to bottom, one will run from centre to outer, one will rotate around the top to bottom axis. This is the nature of 3D polar qualities, and 3D polar qualities are those parts of existence that we can sense. Everything we experience is composed of 3D polar qualities. They are subjectively defined by us and objectively quantified in relation to us. What this understanding gives us is the seamless nature of reality. There are no gaps, no instances of complete nothingness anywhere. One polar quality becomes its opposite through an infinite series of incremental changes that can be arrived at via an infinity of potential routes. In other words, if you wish to change red to green, you don't only have to draw a straight line from the one to the other, passing through perfect grey along the way. Not unless you're doing your math in one dimension. You can get there via blue, or via white, or via black, or via yellow, or by meandering around the interior of the sphere for as long as you like, until you eventually get there. This goes for colour, and this goes for any conceivable quality you could care to consider. Existence is seamless and contains no cases of absolute nothing. You can have zero luma, zero saturation, and zero hue, but this doesn't give you zero everything. It gives you perfect grey, which is still something. You never have complete and utter nothing. When a colour stops being a colour, it has simply changed form and become a different kind of quality. So what I'm showing with this colour sphere is the nature of all subjective qualities. All qualities are subjective, or relative if you prefer. You are at the centre of your own point of view. From your own point of view, anything that is not as dark as you must be lighter than you. Anything that is more green than you must be less red than you. Anything that is more saturated in colour than you must be less grey than you. Now that's just the quality of colour. You can replace these three axes with the three sub-qualities of another quality, like size, or consistency, or flavour, or texture, or whatever, and the very same principles will apply. Really getting to know a quality is a question of identifying its three sub-qualities well enough, and then seeing how they interact with each other, how the one becomes the other. So yeah, three-dimensional complex numbers produced by triads of polar qualities. That's what you want to be using when you are modelling existence with maths, if you want to get all the detail. In due course, I'll be presenting my three-dimensional model of the very quality of existence itself, the foundational quality. But before that, in the next part, we will pause the clock for a moment to understand what time is. So far, I've been claiming that fixing the broken foundations of our understanding of maths should enable us to fill in the gaps, answer the questions that our maths has been unable to answer so far. One of the most notable gaps in our maths is our need for a unified theory of some kind. That sounds rather technical and complicated, but maybe we'll be okay. Because when we are working at the foundational level, we are, by definition, working at the simplest possible levels of understanding. So what, in the simplest possible terms, is a unified theory? Well, we have mathematical models for how physical phenomena behave at the cosmic scale, and also at the subatomic or quantum scale. Relativity theory can predict the movements of planetary bodies, stars and galaxies, moons in orbit, etc. And quantum theory does a good job of predicting the behaviour of existence at the teeny tiny scales. But these mathematical models do not dovetail naturally with each other. Or in other words, we're missing something. So what must a unified field be, logically speaking? A field can only be an ocean of objectively quantified, subjectively sensed, measured, observed, experienced values that move in response to one another. A more scientific word for subjective is relative. Why an ocean of values? Because it must be at least three-dimensional, and it must be entirely seamless. There can be no gaps, no absolute nothing between one part of existence and the next. Conceptualizing seamlessness is a particular difficulty for our current cognitive bias of seeing physical attributes like mass, inertia and energy as indicators of the presence of that which is actually real. Given this cognitive bias, physics has a terribly hard time understanding how a particle of matter here can exert an influence on a particle of matter over here, without the space between them being entirely filled up with other particles of matter. If we start from the same cognitive bias, we will encounter the same difficulty. But we no longer share that cognitive bias. We see mathematical truths as the one foundational phenomenon. So this leads us naturally to the question of, how do mathematical truths result in a unified field? So let's take a look at our three-dimensional model of existence so far. Here we have the three spatial dimensions that are required for any kind of existence. Along with this, we have our understanding that not one speck of this space can be the location of absolute nothing or zero everything. In other words, every infinitesimal location within this infinite space must contain some quality of existence or other. That is not to say that every speck of this space contains what we would recognize as physical particles of matter. It is not even to say that every speck of this space contains a quality that we can even discern. We could take one location within this space, for example, and say, well, this area here contains the quality of light. But if we are literally blind, we will not be able to discern anything there. And just because we can't discern something doesn't mean that there is nothing there. There is never nothing there. It's a logical, objective fact. It's simply true. So we already have an endless and objectively defined three-dimensional space, absolutely filled with an infinity of subjective qualities that merge and become each other seamlessly from one neighbouring region to the next. That is your unified field of existence right there. It can only be like that for the simple reason that it could not possibly not be like that. No other model can work. And whatever qualities are present at any given location at any given time are going to be behaving in accordance with the truths of maths. From this unified field emerge all of the relative effects of existence, such as time, for example. Time is not a thing in and of itself. Time is an effect of the iterational nature of existence. This is very, very simple. In maths, an iterational sequence is a sequence that takes its own output value and uses that as the input value for its own next iteration. That sounds jargony or technical, which maybe makes it sound less simple than it is. Let's have an example. An ordinary one-dimensional number line is an iterational sequence. How do we produce a number line? We take an arbitrary distance from 0 and we define it as 1. This is our first input value. When we process that input value by adding a second instance of 1 to it, this gives us our first output value of 2. The output becomes the input for the next iteration. So now our input is 2. We process it just as we processed the first input by adding 1 to it. This gives us the output for our next iteration, which is 3. And so on and so forth towards infinity. Some iterational sequences in maths are especially noted for the patterns they produce. The Fibonacci sequence produces a nice spiral, and this spiral can be found in the natural world in all kinds of places. Another iterational sequence produces the cardioid. This pattern is called cardioid because of its heart shape. It can be produced when you plot the numbers of the 2 times table as they relate to each other around a circle. This pattern can often be found in your cup of tea. It's created by light reflected off the circular sides of the cup. And a microphone's sensitivity to sound can often be described as a field that is cardioid in shape, depending on the microphone. The cardioid also shows up in the pattern formed by another iterational sequence. This is the Mandelbrot set. Its largest feature here is the cardioid. The Mandelbrot set is perhaps as famous as the Fibonacci sequence because of the way it demonstrates infinity in an exceptionally visual way. The Mandelbrot set is a real mind bender. I encourage you to do an image search online for Mandelbrot set in 3D, and I encourage you to just be interested in it in general. It gets me thinking about all sorts of things. So what is the big insightful point I am looking to make here? Maths makes patterns and so does the natural world. That has been pointed out many times by many people. But once it has been pointed out, we're just kind of left hanging. What are we supposed to do with that observation? For me, as usual, it comes down to the question of whether I can think simply enough. Life is iterational. Existence is iterational. Everything we experience is very clearly iterational. You only have to look at it. Every moment of your life is a direct result of every moment that came before it. And the nature of iterational sequences is this. Everything that has occurred in previous iterations determines the next iteration. The output becomes the input, becomes the output, and so on forever. The truths of maths are absolute truths that can be misunderstood or simply not known about, but they can't be broken or avoided, not even in ignorance. The truths of maths are active truths. The positions and polar qualities of all values, as subjective as they are, have absolutely strict relationships with each other. And when maths becomes iterational, values come to life and exhibit behaviours as their quantities and qualities interact with each other from one iteration to the next. So, existence is the truths of maths observed in iteration. Existence is composed entirely of values, and the objective quantities of the subjective qualities of these values are in a perpetual state of mathematical iteration. They are each changing, or staying the same, in response to the values surrounding them. Take the position of a falling object, such as an apple. From moment to moment, the position of the apple changes in response to its surroundings and its positions in previous iterations. From moment to moment, All of existence is updating itself in response to its own state in the previous iteration, as determined by all of the iterations that came before that. Existence is not allowed not to exist. Therefore, it can only iterate endlessly. When thinking of time and what it is, we need only note that the word now refers to the current iteration of existence. The word past refers to previous iterations, and the word future refers to the iterations this current iteration is leading to. Existence can't do anything but iterate endlessly. Therefore, we have the effect of time. The reason it is possible to remember the past and not the future is because the current iteration is literally made out of the preceding sequence of output becoming input. If we plot a subjective iterational sequence in our three-dimensional value space, which we decide to define as one moment to the next, in 3 dimensions we can see that one moment to the next produces a continuously expanding sphere. As the sphere expands, we can see that all previous iterations are contained within the current iteration, and all future iterations lie outside the current iteration. That is, mechanistically, how it can be possible to remember the past but not the future. My definition of the word number enables us to understand the effect of time, and the behavior of memory confirms my definition of the word number. This encourages me to feel that my foundation is coherent and well integrated. This definition of time does not fit with the whole concept of space-time, which Albert Einstein gave us. I'm aware of that, and I will be addressing it. For now, I'd just like to encourage you to think about 2 aspects of this way of looking at time. 1. Very, very small scales of the unified field, such as the quantum scale, will naturally iterate faster than the scale that humans naturally experience and inhabit. 2. Our science tells us that the speed of light represents the speed limit of the universe, but it does not explain why that specific speed should be the limit. It's simple. Light speed is not the fastest possible speed in the universe. It is just the fastest possible speed we can observe. We do not have the perceptual apparatus to observe anything that iterates faster than our perceptual apparatus, faster than we are existing, than we are iterating ourselves. Light speed is not the fastest possible speed in the universe. It is simply the fastest thing that we, being at the scale we are, can observe before it pops out of existence for us. Just think about it. If a thing moves faster than the shutter speed of your camera, then it moves too fast to exist from your camera's point of view. What exists for us within the observable universe is only that which we can observe, or at least observe the effects of. Anything else literally doesn't exist as far as we are concerned. So think on. As the complex and complicated beasts that we are, humans have come up with all sorts of complex and complicated ways of thinking about time. I say that both space and time are foundational aspects of existence, and if that's true, then they must be inherently simple. They have to be. Foundational properties come into effect too early in the chain of cause and effect to be complex. If you can start thinking simply enough, you'll see that. Complex systems can only be emergent from simpler systems. For example, You can't have a fully functioning human spring into being. You can't skip its development from embryo to baby to child to adulthood. My explanation of time is simple enough to satisfy Occam's razor. It fits our observations and absolutely follows correct maths. Because my understanding of logicism as the foundation of existence is clear enough, I am able to work out what a unified field logically must be, and how it must behave, simply by applying the foundational logic that has been established so far. Then I only have to check the results of my own attempt at logic against my observations of reality. So empirical observations still have their place in this new methodology, but they don't monopolize the whole show and get in the way of us seeing the very thing we are attempting to observe. So here's the end of this first video in the lecture. Proof of nothing has covered the basics. Most importantly, it's corrected our broken cognitive bias around objectivity. This video has been the primer. The next video, Proof of Something, takes us further, continuing the theme of maths meets reality, or maths meets physics. We have a good look at the invisible mechanism that causes gravity, and we explore a few other things that are just too exciting to talk about here. So why don't you stretch your legs and get some fresh air, and we can meet back here for proof of something.